Okay guys, the essential question today is going to be, how can you use a number line to order real life events? The objective is to be able to use a number line to compare and order integers. We have three Common Core standards that we're going to be covering with this lesson. Okay, our first example. Example 1. On a horizontal number line, numbers to the left are less than numbers to the right. Numbers to the right are greater than numbers to the left. So if I want to compare positive 2 and negative 6, I imagine a number line or I actually write out a number line. Here you can actually physically see the number line. But as you guys get better at doing these problems, in your head you can imagine the points on a number line. Okay, I'm comparing positive 2 and negative 6. Positive 2 is to the right of negative 6 on the number line. And numbers to the right are greater than numbers to the left. So I would have to say 2 is greater than negative 6. I'm using the location of each integer on the number line. Negative 6 is on the left, positive 2 is on the right. Numbers to the right are greater than numbers to the left. It's that simple. Now that's if I'm using a horizontal number line. Our second example, we're taking a look at a vertical number line. Right? I want to compare negative 5 and negative 3. When I'm using a vertical number line, numbers below are less than numbers above. Numbers above are greater than numbers below. So once again, if I'm using a vertical number line, I locate these two values on a vertical number line. Well, here's 0, negative 1, negative 2. Here's where negative 3 would be located, negative 4, and negative 5. Numbers below are less than numbers above. Well, negative 5 is below negative 3. So if I'm writing my comparison, I would write negative 5 then is less than negative 3. All right, because numbers below are less than numbers above. All right, it's very simple to compare integers, but I have to imagine a number line to do it. Okay, why don't you guys stop the video for a second, try these three on your own. Imagine a number line, or actually write out a number line and locate each one of these integers on a number line and use that number line to compare. All right, now I'll go ahead and do the problems. If I'm looking at 0 and negative 4, all right, I'm just going to draw one big number line here and help me locate these integers. Here's 0, here's 1, here's 2, here's 3, here's 4, here's 5, 6, 7, and 8. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. Here's 0. Here's negative 4. Negative 4 is to the left, or I'm sorry, 0 is to the right of negative 4. So 0 is greater than negative 4. Negative 5 and 5. Here's 5. Here's negative 5. Negative 5 is to the left of 5. Negative 5 is to the left of 5. So that means then that should be less than. Negative 5 is less than positive 5. Okay? Our third example, I have negative 8 and negative 7. Here's negative 8. Here's negative 7. Negative 8 is to the left of negative 7. And anything to the left is less than. Okay, so you can either sketch the number line if you want, or just use an imaginary number line when we're comparing integers. Okay, if I want to order integers, We usually order integers from least to greatest. One method we can use is to graph each integer on a number line. So I write out my number line. I want to order the following integers: -4, 3, 0, -1, and -2. I want to order them from least to greatest. So first, I graph -4 on a number line, 3 on the number line. Here's 0, here's -1, here's -2. So first, I draw my number line, and just like the previous problem I did, I graph each one of these integers on a number line. Then I write the integers as they appear on the number line from left to right. So the first integer I see is -4. Next integer I see from left to right is -2. The next integer I see from left to right is -1. Next integer I see is 0. The next integer I see is +3. So I start by graphing each integer on a number line. All right, so I locate each one of these integer points on a number line. Then I write the integers as they appear on the number line from left to right. All right, and that's what example 3 would look like. I've taken my original integers and I've ordered them from left to right, and I just use commas to separate each integer. Next slide. Sometimes you get some problems where you have to reason and use common sense. So let's take a look at the question. A number is greater than -8 and less than 0. What is the greatest possible integer value of this number? Now it's a multiple choice question, so we have 4 choices: -10, -7, -1, and 2. Now right away we should be able to eliminate which one of these answers, because it's not less than 0. Which one of these answers is not less than 0? Correct. 2 is not less than 0. So right away I can eliminate answer D because it's not less than 0, right? And I am reasoning with my understanding of integers. A number is greater than -8. Well, -10 is to the left of -8, right? So I can eliminate then -10 as a potential answer as well, because -10 is to the left of -8. Okay, so now I'm left with -7 and -1, and I want the greatest possible integer value that is greater than -8 and less than 0. Well, here's -7 and here's -1, right? I have 2 numbers left, so I'm going to compare these 2 numbers. Which one of these numbers is greater? All right, correct. -1 is going to be greater because -1 is to the right of -7. Okay, so the correct answer then here is going to be -1, which is answer C. Let's move on to our next question. Real life application question. It reads, the diagram shows the coldest recorded temperatures for several cities in Virginia. I see Roanoke, Virginia. The coldest recorded temperature is -11. Lynchburg, Virginia, -10. Richmond, Virginia, -12. Norfolk, Virginia, closer to the water, right, -3. Wallops Island is 0. Right? So Wallops Island has not recorded a negative temperature. Right? They've only gone down to 0. Question A says, which city has the coldest recorded temperature? Well, first, once again, we can graph each one of these integers either on a vertical number line or a horizontal number line. Doesn't matter. Right? So the textbook chose a vertical number line here. When I look at all of my recorded temperatures, I have Richmond at -12, Roanoke at -11, Lynchburg at -10, Norfolk at 3, Wallops Island at 0. So once I have my number line set up and I have all of my temperatures located on my number line, it's going to make the question very simple. Which city has the coldest recorded temperature? Correct. Richmond. All right. All right. Richmond is the lowest on our vertical number line. And when we know the number line is vertical, the lower the temperature, or the lower you are on that number line vertically, the colder the temperature. So Richmond at negative 12 degrees. All right, that's your coldest temperature for part A. Part B says, has a negative Fahrenheit temperature ever been recorded on Wallop Island? And we see that Wallop Island, the coldest recorded temperature is 0. So has a negative Fahrenheit temperature ever been recorded on Wallop Island? No, it has not. All right, no, because 0 is the lowest temperature recorded. The lowest recorded temperature. All right, I'm just going to abbreviate temperature. Okay? Okay, you guys try the on your own problems here. Questions 4, 5, 6, and 7. I'd say stop the video. Use the strategies that we've used in the previous problems to do them, to do problems 4, 5, 6, and 7. All right. Stop the video now, and then you can pick it up and I'll go through the answers. Okay, let's look at question 4. Order the integers from least to greatest. All right. Now, since the numbers are small, I'm going to locate each of these on a number line. Okay, so we have, I start with 0. We have 1, 2, 3, 4, negative 1, negative 2, negative 3. All right, let's start there. I see negative 2. I see negative 3. I see 3. I see 1. Then I see negative 1. So if you remember the strategy from the example problems, the first strategy is to locate each of the integers on a number line, right? So that's what I did. I located each one of these integers on my number line. And then we just list them in order from left to right. So if I'm going from least to greatest, negative 3 is the least because it's furthest left. Then we have negative 2. Then we have negative 1. We have 1. And we have 3. So that would be problem 4. Problem 5, right, the numbers are a little larger, so for laziness sake, I'm not going to write out the number line, but you can imagine where these points would be on the number line, right? Which one of these integers would be furthest left on the number line, right? Would be negative 8. So negative 8 and then negative 7 are the only values that are less than 0. So they're going to be your lowest values. Negative 8 is further left on the number line than negative 7 is. Then as we continue, I would have 1, 4, and 6. 1, 4, and 6 in order from least to greatest. Okay? In example 4, what is the least possible value of the number? So let's go back to example 4. And I want the least possible value of the number. Well, if it's greater than negative 8, it means it has to be to the right of negative 8. If it has to be less than 0, it has to be to the left of 0. So what would be the least possible value of all the numbers that fit that number? Correct. Right, it would be negative 7. So I'm going to go back here where we were doing problem number 6. Problem number 6 should be negative 7. Then finally, in example 5, Norfolk recorded a new record low temperature last night. The new record low is greater than the recorded low for Lynchburg. What integers can represent the new recorded low? Okay, well, the new recorded low has to be greater than the record low in Lynchburg. Okay, well, here's Lynchburg. Right, the recorded low for Lynchburg was -10, and the new recorded low has to be less than -3 but greater than -10. So we're looking at all of the integers from -4, -5, -6, -7, -8, and -9. So it's -4 to -9. So if I'm doing problem 7 should be -4, -5, -6, -7, -8, and -9. Those are all of the possible integers for question 7. All right. Now the last page, all right, I'd like for you guys to work on are the practice problems. All right, you're going to practice 6.2, problems 1, 2, 3, 4, 5, and 6. And then you guys would do problems 7, 8, 9, 10, and 11. Okay, now you can rewind the video and pause the video, right, to do these problems. All right, check your work. Okay, stop the video right now and then pick it up when you are finished, and then we will check our answers. Okay, so let's start with problem number 1. 0 and 9. I'm comparing and ordering these integers. 0 is to the left of 9 on the number line. Problem 2. 8 is to the right of -3 on the number line. It's going to be greater than. -5 and -7. -5 is to the right of -7 on the number line. That means it's going to be greater than. -12 is to the left of 0. So that's going to be less than. -6 is to the left of -2 on the number line. So -6 is less than. -21 is to the right of -40, right? If I draw my number line, -40 is all the way down here. -21 is going to be to the right of that. So -21 is to the right of -40. Means it's going to be greater than. If I take a look at problems 7 through 11, we're ordering from least to greatest. The strategy is to take a look at each one of these points on a number line. I'm not going to draw the number lines. I'm going to use an imaginary number line in my head, right? But you guys should probably draw out your number lines. Okay? Problem 7, from least to greatest, furthest left is going to be -6. Then we have -3. Then we'd have 0, 1, and 5. Okay, so problem 7 should look like that from least to greatest. Problem 8, your furthest left is going to be -9. Then you'd have -4. Then you'd have -1. Right, so I take care of all my negatives. Then my positive numbers, I'd have 2, and then I'd have 3, moving left to right on the number line. Problem number 9, -18 is furthest left. Then we'd have what? -11. Then we'd have -8. Then moving left to right, we'd have 11. And then we'd have 18 from least to greatest. Problem 10, -35 is your least. So that'd be your first from least to greatest. -14 would be next. -7 would be next. Those are all of your negative numbers. Then your positive numbers, you'd have 21. And then you'd have 28 from least to greatest. And then finally, problem 11, your miniature golf scores for the first half of a course are the following. Order those scores from least to greatest. Well, I'm looking for my greatest negative number, and it looks like that's going to be -5. Cross it out so I keep track. Then we have a -4. Cross that out. Then it looks like we have a -3. Cross that out. Looks like we have a -2. Cross that out. Then we have a -1. Then I have a 0. And then I have a 3. then I have a 4. Now, because these numbers were smaller, right, I could locate them on a number line, and I just noticed that, hey, I forgot that positive 7. But I realized that I forgot positive 7 because I crossed out the numbers, okay, as I ordered from least to greatest. So I got to make sure I include positive 7 in my answer, okay, and then I'll cross it out because I know that I've used all of my values. All right, guys, that's the end of the lesson. At this point, you guys are going to work on the exercises for examples or exercises 6.2, and do your best with it. Thank you.